Okay, now it's time to test a population mean. We just got done talking about in the last video testing a population proportion. This would be a categorical variable. Yes or no, have you had an AP class? This one's going to be a quantitative variable. How many grams does the iPhone 6 Plus weigh? So I looked it up. It's supposed to weigh 129. You, 5 years in the future, maybe more, you're a quality control engineer at Apple, making the big bucks. Your job in life is to make sure that Apple iPhone 6 Pluses weigh 129 grams. So how do you do that? You go out and sample some, and you take a sample and see what do these 500 weigh on average. Now you're going to have a little bit of variability, but are we okay with this much? This is the question. All right, how unlikely is it that we get a sample like this if in reality we are at 129? Okay, so let's go through the steps. We're going to do our WHAPs. What test are you doing? All right, I will complete. I will do a one sample t-test. We're in mean world now, so we're in t's, not z's. All right. A one sample t-test for the mean weight of the iPhone 6 Plus. All right, get a little context in there. You can never go wrong with some context. What are we testing? We're testing what's the average weight of these iPhone 6 Pluses. Okay, H, hypotheses. The claim or the standard or the goal or the target, all ways to interpret the null hypothesis, is that the true average, the population average, this is a parameter, not a statistic, mu equals 129. Okay, a common mistake would be to do x bar equals 129 or p equals 129. X bar is closer because at least it's a mean, but hypotheses are in terms of the population. Alternative hypothesis. Mu is. Now, you go to work this day, you do not have in mind, are they less than or are they greater than? You are checking to see, are they not equal to 129? Okay, this is a more rare instance, but I'm going to use this time to do a two-sided test where the alternative is not equal to, because we need to get at least one good example. Usually you have in mind higher, lower. In the real world, you're probably going to be testing with one of those things in mind. We're just going to do this one two-sided because it'll come up from time to time and you need to be ready for it. Okay, so null hypothesis, the mean is 129. Alternative, it is not. Assumptions and conditions. I need, get rid of that for a minute. I need random, normal, and independent. Okay, a basic sentence that just says, took a random sample. It said so. Please don't write SRS check mark. All right. It says up there, I randomly sampled 500. Okay. In real life, I'm probably going to do more of a systematic sample, like choose one every minute for 500 minutes or something like that. But it said it was random. All right. Normal. Is the weight of iPhones normally distributed? Or do I care? Well, in this case, I do not care. N equals 500, which is greater than 30. Okay, so my sampling distribution is normal. So my normal condition is met. Independent. So what needs to happen The condition is that one iPhone is independent of the next. All right, the weight of one does not affect the weight of the next. The way that I check to see that that's going on is I don't sample too much of the population. So 500 is less than 10% of all 6 pluses. All right, so random, normal, and independent. We've been using these conditions for a while, so there they are. WHAP, perform the test, or find the p-value. Okay, so again, in this video, we're going to do this by hand, and then later we'll realize that the calculator will do it quicker. But you got to know, you got to understand how to do this by hand. Okay, so this t that we're getting ready to find is my test statistic. It is like a z-score, but since we're in mean land, we have to deal with the degrees of freedom and all of that business. So what we're going to do is sub into this, find the test statistic by hand, and go to the tables to find the p-value. So x bar, that's my average, my sample average, sample mean, 129.07. So you might already be thinking 129.07 is barely over 129, the goal, all right? But we've got a small standard deviation, which means anything not really close to 129 might be rare, and we're also looking at a sample of 500, all right? Minus mu sub 0, this is the null hypothesis mean, 129. Over S sub x, it's my standard deviation, sample standard deviation, 0.5. It's unrealistic to assume we know the population standard deviation. If we did, we could just use z's, but we do not, so we use t's, over the square root of 500. So let's get our t statistic the old-fashioned way. Our t statistic, numerator, 129.07 minus 129, that's just 0.07. I didn't really need those parentheses, but I subtracted in my head. Divided by, you do need parentheses around the entire denominator, or else you will get a mistake. 0.5 divided by square root 500, close the square root, close the denominator. And my t statistic is 3.1305. All right, so you can think of that as kind of like a z-score, but we can't use the same conclusions. That would have been a huge z-score. We don't know if that is a huge t-score or not because it depends on the line in the chart. So here's where we are at this point. You're not going to have to draw this every time, but just humor me. What we are trying to find is the likelihood that in this particular t distribution with the certain amount of degrees of freedom, we're trying to find the probability that our sample is as far away from the middle as the one we got. Basically, we want to find the sum of that area and that area. Why is it 2 areas? Because my alternative hypothesis is not equal to. You can't just say, well, my sample was on the upper end, so let me just do this area. That's cheating. You have to know your hypotheses before you get your data and before you decide. You can't just decide afterwards. If you're testing a not equal to, then you test a not equal to the whole way through. So how do we find that area? Let's go to the tables. This is, let's see, 3.13. This is your T table, the same one you'll have on your exam. Degrees of freedom first. We have a sample of 500. I have to go up to 100. Okay. Now, I look for my t-score, my test statistic in the chart, in that red line, it was 3.13. I'm not going to find it exactly. What I'm going to find is a range where it's between. 3.13 is between 2.87 and 3.17. It's closer up to the 3.17 end, but all that matters is where it's between. That means, if I follow those two up, my p-value is somewhere between 0.0025 and 0.001. You're not going to get, if you're doing this by hand, an exact p-value. You're going to get a range. But all the important cutoffs are up at the top of that page. All right, so this is 0.0025. That's a fourth of 1%, and 0.001 is a tenth of 1%. So what I know right now is that 0025 and 001, my p-value is somewhere between that. I should reverse those, excuse me. Now, keep in mind, that's the one-sided. So that's not really my p-value. That's just 1/2 of my p-value. When it comes down to a difference in a one-sided and a two-sided test, you're going to double p from the chart. All right, I need this much area above and this much area below. That's the only difference. So I still don't have a specific p-value, but I double these. And I have somewhere between 0.2% and 0.5%. Now that's not 2 and 5% again, that's 0.2% and 0.5%, both well under 1%. And therefore well under 5%. We're testing at the 5% level, which means anytime my p-value drops below 5%, that's evidence to reject the mean, or reject the null. So what does this mean? The claim was that these phones are averaging 129. My average, 129.07, would be nearly impossible if in reality the number was 129. So how could that be? It's so close. Well, kind of like I said before. First of all, we're looking at a sample of 500. And secondly, the standard deviation was only 1/2 gram. And then we divided that by square root of 500 to get the standard error, which means, again, 129.07 is almost impossible in a world where 129 is actually the average. So let's get a conclusion. S and WHAPS, state your conclusion in context. We reject the null hypothesis since P is somewhere between 0.002 and 0.005, which is basically impossible if you think about it. And it's even closer to the 0.005 stage. We reject the null since P is here. There is sufficient evidence to conclude that the true mean weight of iPhone 6 Pluses is not equal to 129 grams. Now, key, not equal to. Our alternative hypothesis was not equal to, okay, which means we reject the null and we go with the alternative, which is not equal to. You don't want to go greater than, even though your sample indicates it's obviously greater than. Once you're, like I said, once you decide to test not equal to, you are just testing not equal to. You don't go back and conclude that it's greater, even though it seems pretty obvious that it is greater. Okay, so test for the mean, one sample, WHAPS. We're going to find the mean weight. We're going to test for the mean weight. hypotheses, equal to 129, not equal to, random normal independent, find your test statistic, your t, double the p-value from the chart because it's two-sided, make your conclusion. All right? Quickly, let's see what our calculator says. If I go to stat tests, this is a t-test. All right, if it's a proportion, it'll say prop. That z-test at the top we will rarely ever use. We are using t-test. What I want to put in is the data. No, I want to put in the stats. I don't have all the 500 numbers. I have the average. The null hypothesis is 129. The average is 129.07. The standard deviation of my sample was 0.5. The N was 500 phones, and I'm testing for not equal to. If you hit draw, it'll draw you a little normal curve. If you hit calculate, it'll just get straight to it. So what do we get? See the 3.13? That's our T that we had right here. Our p-value 0.0018. So we had it somewhere between 2 and 5, 0.2 and 0.5. Remember, I had to go several degrees of freedom up to use the 100 line, even though I was using the, even though I had a sample of 500. So you can see how the calculator is a little bit more precise. Gives me an even smaller chance because it was a sample of 500, but we're close using the chart. All right, so that 0018 is almost, we were on this end of the interval, and if we in fact use the 500, it pushes it beyond 002. But no problem. That's the difference between calculator and by hand. But you need to understand both, so make sure you do. All right, that's going to wrap this one up. Testing for the mean. Young out.